Hi friends, welcome back to chemistry classes. So today we are going to start the another chapter, that's IUPAC or IUPAC nomenclature. This IUPAC nomenclature is based on naming a molecule's longest chain of carbons connected by single, double or triple bonds, whether it may be a chain or a ring or something else. This IUPAC is a branch of chemistry, or this is the institution, or this is a company. You can tell something. This IUPAC, you can tell this also as a method. This IUPAC nomenclature is based on naming the molecules. This helps the compounds to name the molecules. It has different rules and regulations, and it has different methods in it. So just basically, if you tell IUPAC is a nomenclature, or IUPAC is something that names the compounds or anything that's related to carbon. Here, the common definition which we read is IUPAC nomenclature is based on naming a molecule's longest chain of carbons connected by single, double, or triple bonds, whether it be in a chain or in a ring. As already I had told that chain isomerism, ring isomerism in the isomerism chapter, you can see that, and there you'll get to know about this all. Here chain means it will be straight, and ring means it will be curved and it will be attached. I have told this in classification of organic compounds chapter, so you can see that. And here, how to name these compounds. Here, how to name means it's based on, primarily it's based on number of carbons in this compound. Here, how many number of carbons are there? So name will start like that. Here, when number of carbons are 1 in the compound, then we call it as, then we start with meth, METH, meth. When number of carbons are 1, then it's meth, and when the number of carbons are 2, then it's eth, when it's 3, prop, when it's 4, but, when it's 5, pent, and when it is 6, hex, and when it's 7, hepta. These 7 are important, and until 5 they are most important. Until 5 they are very important. They may be not go until 7, but until 5 these are very important to know the names. Here one is meth, second one is eth, third is prop, fourth is but, fifth is pent. These are the 5 names for carbon atoms on the basis of their numbers. You can note it down. That's number of carbons: 1 it's meth, 2 eth, 3 prop, 4 but, 5 pent. Next, number of bonds. Here, if it's single bond, if it's one bond, we tell it as ane. If it is one bond, we tell it as ane. If it's 2, then ene. If it's 3, ine. That's yne. Here, when number of bonds are 1, then it's ane. Number of bonds are 2 between carbon and carbon, then it's ene. And number of carbons or number of bonds, it's 3, then we call it as ine. That's yne. Here, this is the naming format of IUPAC. That's first prefix, primary prefix, secondary prefix, root word, primary suffix, and secondary suffix. This is the root word. In the next video, you will be going to learn about those functional groups. Then I will come to know about this prefix and suffix. So now there is still one main important in this naming. When you name any ring compounds, then prefix is cyclo. Cyclo is confirmed for any of the ring compound. First we write cyclo, and then we started naming, because cyclo means it's a reverse, it's circle, it's ring, so we call it as cyclo. So when there are ring compounds, every time we start it with cyclo word. Now CH4, here according to IUPAC, one carbon, it means it's meth. Here one carbon means meth. So let's write until here. Then H4, how to find that this is single or double or triple bonds? So I think you know about these formulas. That's CnH2n plus 2 for alkane. Next, alkene, CnH, 2n for alkene, and CnH minus 2. So according to these three formulas, here number of carbons are 1. When we substitute here n value 1, that's only C, and here 2 ones are 2, 2 plus 2 is CH4. Then it's alkane. Then single bond, it has single bond, so it's alkane. Then it ends with ANE. Then meth plus N. Here the compound, this CH4 is known as methane. So its structure is carbon with 4 bonds, 1, 2, 3, 4. So 4 serrates with hydrogen, CH4. This is structure of CH4. Here next C2H2, and it's C2H2. Then when there are two carbons, then we write eth and H2. Here H2 means according to formula C2H2. When there are two, we write 2 2s are 4, 4 minus 2 is 2. So C2H2 belongs to YNE, that's 3 bonds. Carbon with carbon, 3 bond. So here we get ethine. Here ethine and carbon with carbon, 3 bonds, and still one bond is left for carbon, so H and H. It's completed 2 carbons and H, so it's ethine. Next C3, 3 means pro, P-R-O-P, pro, and it is C3H4. When it's C3H4, according to formula, here when we substitute here n value 3, 2 3s are 6, 6 minus 2 is 2 again, it's triple bond, again it has 3 bonds, so we get propine. And like this, when it is carbon with 3 bonds, and here one hydrogen is left, and here one bond, here again H3, here triple bond H3, so C3H4. Here it's HC, triple bond C, one single bond C, and again triple bond H3, so C3H4. This is propine. Next CCl4. Here CCl4, this is different from everything. Here we name it according to, there are two names, that's trivial name is which we call it as common, and IUPAC name is which according to this method. According to this method, this is when it comes to single carbon, then it's meth and 4Cl, that's 4Cl with tetra, 4Cl with single bond, so meth tetrachloride. Instead of this, it will be not possible, so we'll write this in trivial name as carbon. We write it as carbon, this is carbon, here 4 chlorine, so tetra, carbon tetra chloride, so it's carbon tetrachloride. Here one carbon and 4 chlorines, so it's carbon tetrachloride. Again here next CH3OH, here it's CH3OH, so OH is separate and CH3 is separate. This is different case. Here when it comes to OH, it's a functional group. As I already told, OH is a functional group. Here OH will have suffix OL, OH will have suffix OL, and here it's CH3. When we try to draw its structure, here already 3 bonds are completed. Here already 3 bonds are completed, and here again here one bond is left. Instead of hydrogen we replaced OH. So for oxygen it's 2 bonds. Oxygen valence is so for oxygen 2 bonds, and for carbon 4 bonds are completed, and for this 1 bond. So CH3OH. For OH suffix is OL. We'll tell for OH suffix is OL. So here 1 carbon and everything is with single bond, so it's meth and all. We write it as methanol. So this is a new example, that's meth and all. And here next, they given name, we should only draw the structure. But means 4 carbons. So but is 4 carbons, 1 2 3 4, 4 carbons with double bond. Here this is with double bond. According to formula, 4 carbons. According to ene means double bond. So according to ene, CH2N. Here carbons are 4. So C4H8. So carbons, if 4 carbons are there, then we need to get at least or maximum 8 hydrogens. Here still 2 bonds are left. So we can write it as H and H. Here H and H, and here at finally again double bond. Again here we get H and H. Already 4 hydrogens are completed. Here H, here again H. Here all bonds are completed for carbon. Here 2 bonds, here 2 bonds, here 2 bonds. For every carbon it's balanced, but still there are some hydrogens left. Still there are 2 hydrogens missing. So we remove this bond. And for this carbon still 1 bond is left, and for this carbon 1 bond is left. So we write it as here other H and here 1 H. So here it's double bond E and 4 carbons. So butene here. So please don't confuse with this. Here it's double bond. Here it's double bond. So we write it as ene. This is the double bond. So this ene and 4 carbons, 1 2 3 4. According to formula, carbon should be 4 and hydrogen should be 8. Here 4 carbons and 8 hydrogens, 1 2 3 4 5 6 7 8. 8 hydrogens. So this is chemical structure of butene. So this is the end of the class. If you have any doubts, please post in the comment box. Please like this video, share and subscribe to our channel, that's Study to IT. Have a great day.